Hello, this is Miss Baker with a very bad cold, making this recording during the Christmas break. I'm going to be introducing you to how to set up and run a simulation to calculate an empirical probability. And I will give you the steps, and I expect these steps to be followed every time you do a simulation. The first thing we need to talk about, is how you use your calculator to generate random numbers. You'll need those random numbers generated as you work, and this is the easiest way to do it. You'll see a screenshot. You hit your math key that's on the left side right under your alpha key, and tab left once, right 4 times to get over to the PRB menu. Number 5 on the PRB menu is random integers. If you just hit rand, you'll get a random number between 0 and 1. I think it was with 7 or 8 decimal places. And that, if you just need a list of random numbers, that can be helpful. It's more like 10 random numbers. The random integer is a little better for our purposes, because it'll give us those random integers we'd like. The format is to put the random integer function, put the first number of the range you want, comma, last number of the range you want, comma, and then the number of numbers to select from that range. If you don't put in that last number of numbers, it'll just generate one random number from that range of numbers you've specified. So here's some examples. If you hit random int 0, 1, you're going to get one random number from the range 0 to 1. So it's either a 0 or 1. And if you've got something that's a 50% chance of happening, this works very well. You could let it be a coin toss. 0 is heads, and 1 could be tails. Random int 1, 6 will give you a single random integer from 1 to 6, which simulates rolling a die. The same function, but with a 2 added, would be like rolling 2 dice. And you just keep hitting enter, and it'll keep doing the simulation. So you don't have to go back and hit math, PRB, random int each time you want to do it. One that we're going to be using in this video is random int 1, 10, 5 to choose 5 numbers from between the numbers 1 through 10, and is with repeats. And that sometimes will affect your simulation. It won't in this case. I don't know why that's all there again. That's a weird thing. So these are the steps for every simulation. First step, identify the component that is going to be repeated. Explain how you model the outcome. Explain how you simulate one trial. State clearly what the response variable will be. Run several trials, and analyze the response variable. State your conclusion in the context of the problem and in context of a simulation. The problem we're going to be looking at is the one on the handout where the upper school is 30% seniors and sophomores, and 20% are juniors and 20% are freshmen. So Miss Baker picks a group of 5 students to go to the casino for a field trip. She doesn't pick a single senior, and the seniors are irate. We're interested in what's the probability of that happening, me selecting 5 students and not picking any seniors. Okay. So the component to be repeated is we're going to randomly select 5 students from the upper school. And you want to, I know writing takes so long, but you actually are going to need to write these things out. The next, how will you model the outcome? And since the probabilities are all multiples of 10, I can just use the 10 numbers from 0 to 9 to simulate the outcomes. When I first set this up, I thought I'd use 1 through 10. But 0 and 1 will be a freshman, 2, 3, and 4, sophomore, 5 and 6 will be a senior, 7, 8, and 9 will be a senior. That way, in general, your outcomes, you have a 20% chance of drawing a freshman, a 30% chance of drawing a sophomore, and so on. The way you set up what your random numbers will represent have to follow the probabilities you're given in the problems. Next step, how will you simulate one trial? I will generate 5 numbers using the numbers 0 through 9 and check to see which classes are represented. What will the response variable be? In this case, I'm interested in how many seniors are in that group of 5. That's going to vary from that response variable is the outcome that I'm interested in, and I want to keep track to find what's the probability of not getting seniors. So you run several trials, and you've got to do at least 25. So my first run, I came up with a number 03927. Now remember, a 0 is here. That 0 is a freshman. The 3 is a sophomore. A 9 is a senior. A 2 is again a sophomore. And that 7 is a senior. So how many seniors? There are 2 seniors. The next time I ran the simulation on my calculator, I got 23091. So that tells me I have a sophomore, I have another sophomore, I have a freshman, that's the 0, and I have a senior, and I have a freshman. I have 1 senior out of the group. Then I have, the next one was 58921, and out of that group, the 8 and the 9 represent 2 seniors. Now, when you're doing one of these problems, you need to show me some of the outcomes of your random number generation with the response variable noted for that run. And then you can do what I've done in the next one. I can summarize how many seniors I got in the next 23 trials. Okay, so I've done 25 trials, and I just wrote down how many there came. I want to see what you did when you run your simulation, so I want to see what was there. Then you can summarize it the way I've done here. Now, out of the 25, I only had 2, this one here and this one here, where there were no seniors. So that's 2 out of 25, and that's 0.08 or 8%. So this is unlikely to happen by chance. So the seniors have a right to be irate based on this simulation. So what I'd like you to do is do the same set of steps with this problem. Owners of an ice cream shop hold a promotional special. They roll 2 dice. Oh, you know how to simulate that. And the price of a small ice cream cone is the greater number followed by the lower number. If you roll a 5 and a 3 or a 3 and a 5, the price is going to be 53 cents. Use the simulation to find the probability of the price being less than 40 cents. So I want to see all those steps, and we'll talk about this tomorrow.